These are your 1-8 notes on interpreting graphs of functions. So we've graphed a little bit with lines, and this just seems like a good place to put this concept. It was in chapter 1. It just seemed a little earlier, or too early, because you really hadn't graphed anything yet. So some of this stuff's going to seem like review, and then other stuff's going to be brand new vocab. So it's all about understanding what a graph is showing us. We're going to go through all the different details about a graph. So the first thing we're going to talk about is intercepts. This is a review. Intercepts are the points on a graph where the graph intersects an axis. The x-intercept is the point where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. So in this particular case, we've got time, 0, and it looks like 1, so 1, 0. So after 1 hour, the temperature is 0 degrees Celsius, and at 0 time, we were at -5 degrees Celsius. And so that just, we talked about this on our last quiz, the before and after, what each of those means. So for a y-intercept, that's before the data occurred. So this is sort of like your before something happens, and your x is your after. After so many hours, we reached this temperature, or at 0 degrees. Before we even begin measuring the time, the temperature was at -5. Then we're going to talk about line symmetry. Some graphs have line symmetry, and it's when a vertical line can be drawn down the middle of the graph, and the two halves match exactly if folded on that line. And so this graph here, that pink dotted line, is line symmetry. And then end behavior is just something else I can use this graph to help explain. It explains how the graph will continue to move in each direction. So it describes that the graph is increasing or decreasing for both the x and y values. You're really describing the two ends. So some graphs only have one arrowhead, but in most cases, we extend these graphs forever and ever in each direction. So my end behavior here, this arrowhead, is telling me that arrow is not just going down, it's actually going to the left, and it's going down. And so when we go to the left, that's your x value, and when we go down, that's your y value. Left is a decreasing x, and your y going down is also a decreasing y. So that end behavior, we would say, as x decreases, goes further to the left, y decreases. Then on the other side, I have another arrowhead, and that arrowhead is not just going down. We can never just go in one direction, otherwise it wouldn't be a function. And so this arrowhead is not going straight down, it's moving to the right as it's going down the page. Our right motion is a positive x value, down is a negative y value. And so what we can say to summarize that, as x increases, y decreases. And then even better yet, what we'll do as we work with these things, you look at the actual data, you talk about launching an object. After so much time in seconds, there's a different height in meters. And so what happens is this x turns into time in seconds, and you replace y with height in meters. So as time decreases, my height decreases. As time increases, my y value also decreases, because the further it goes, eventually the object is going to fall again back to the original spot. Extremas are the highs and lows of a graph. So think of them as the extreme values of a graph. Relative maximas, think of max. It's the highest point of a graph, the peaks. There can be more than one. It's relative to the points around it. So it's the highest in that particular area. And then relative minimas is just the minimum value of a graph, so the lowest point. So I like to think of them as the peaks and the valleys of the graph. So when we locate those, this would be a relative maxima. And usually what we'll say is the x-coordinate. So where does it maximize? It maximizes when x is equal to 2. And then the minima is down here. And the relative minima is when x is equal to, looks like 4. So you're talking about how high up it goes and how down it goes, but we're given the x-coordinate of that. So when we talk about this in terms of stock values, time since opening bell, the stock value maxed at 2 hours after the opening bell. The maximum value would be the y value that coordinates with this, so somewhere around here, just under 3 points. And then the minimum value of that stock for that particular day happened about 4 hours after opening bell, and that minimum value was just almost -2, about -1.5 units, or points, I should say. So just making sense of it all. To make sense of the graph, though, again, you have to take in consideration the title and then the labels of your x and y, what those x and y's represent. Now, these don't really have a name, a specific name, but we can also describe the positive and negatives of a graph. And so the positive and negative values of the graph is comparing it to the x-axis. So when is the graph positive? That's when it's above the x-axis. And the graph is negative when it's below the x-axis. Oops, it should say x-axis here. That's a typo. So our positive and negative values are in reference to the x-axis because values above the x-axis are positive. So the stock values were positive from 0 hours all the way to just past 3 hours. So what we can say is the stock value was positive between 0 and say 3.1 hours. Just an estimate. Then again, after this point right here, which is just beyond 4 hours, we went positive again. So we'd say then again, after 4.6 hours. I'm not worried about the decimal, we're just guesstimating. Then if you look at that other section, when we're below the x-axis right here, where the graph is negative. And so the stock value is negative. So the stock value was negative between, now since I gave 3.1, that's where I left off, 3.1 and 4.6 hours after opening bell. So those hours were after they open up the stock market in the morning. Using the stock values one last time here, we can talk about increasing and decreasing on a graph. There's no special name for this, but it's a description. So a graph increases when the graph is rising between extremas, and it's decreasing when the graph is falling between extremas. So we read this graph from left to right. We have a rise here. From left to right, the values are going up. We were increasing. So my values, the points, so now we're talking about the y values. Points increase from, or stock values were increasing from 0 to 2 hours, because that's the range right here, 0 to 2 hours. And then we can just walk our way through. From that point, 2 hours to 4 hours. From 2 to 4 hours, values or points decreased. The stock value is measured in points. And then we go back up. So at that, so right between, we're at the maxima here, and then the minima here, it switches again. And so we're going back up on a rise. Even though that kind of has a hinge in it, it just means that it's still increasing. It just increased at a different rate. And so increases from 4 hours until the end. So you just read the graph from left to right, looking at, is the graph going up or is it going down? Is it going up or is it going down between the extremas? So number one, I didn't talk about linear or nonlinear, but if you look at it, that is a line. So this is a right whale population. I have no idea what a right whale looks like. So we're talking about whales, population, and then generations since 2007. So the x-intercept is where it crosses the x-axis, which is right here. They're counting by twos. So my x-intercept is 10, 0. And my y-intercept is way up here, and we can call that maybe we're counting by 40s. So this right here would probably be like 250 or so, 260. So my y-intercept is 0, 250. Now if we talk about whales, the 10 is the generations. And so after 10 generations, since 2007, they're talking about after 2017, or 10 generations. I don't know if they're talking about years or just generations of 10 different grandparents, great-grandparents of whales. So after 10 generations, population will be 0. So they can kind of predict the future for these whales. For the 0 to 50, that tells me in 2007, the population of these whales was about 250 right whales. So that's before we even started measuring. When we began this study, there were 250. They're noticing that they're on a decline. When is the graph positive? All of this is positive. You can't have a negative amount of whales. So this is positive from 2007, because that would be year 0, all the way to 9 years later. So we can say to 2016. Or we could say from 0 to 9, but it's nice to put it in the context of the graph. When is it negative? Never. It can't be in this sense, because you can't have a negative amount of whales. When is the graph increasing? It isn't. It doesn't increase. The whale population is on a decline. So when is it decreasing? From 2007 on, it's decreasing. And the end behavior, we can describe those two arrowheads again. So there's an arrowhead up here, and that arrowhead is pointing up and to the left. So what we can say is as x decreases, y increases, which kind of, when x decreases, that's time before 2007. There was probably more whales populations. And then if we describe this arrowhead here is going to the right and down. So as x increases to the right, y values decrease. The more time that goes on, the more the whale population goes down. Okay, I'm going to save this one for in class to kind of just wrap our brains around a little bit better. So I didn't give you a lesson summary here today because I wanted to use that space to give you the graph. So I want you guys to just give me 2 pieces of this information, describe the end behaviors. If you can put it in words in terms of deers, a deer population, time, and number of deer, that would be great. And then the end behavior, extremas, and does it have line symmetry, yes or no? So 3 parts to that practice problem. Good luck.